Hello guys, I'm Raj and welcome back to my YouTube channel. In this episode of competitive programming with Python series, I will be solving this lead code problem, which is set matrix zeros. So let's go towards the problem statement. So this is categorized as an medium problem in Leetcode platform. So we'll be given an m cross n matrix, which will be having some integer values. So we need to find an element 0, and we have to set the entire row and column of that 0 value by 0. So giving a small example of it. So here I have a matrix of 0, 1, 2, 5, 2, 0 and 4, 9, 8. So I have to transform this matrix somehow such that I convert all these zeros, rows and columns as 0 values. So here I will be scanning the elements one by one. If I encounter a 0, I will transform all the elements of that row and of that column into 0. And similarly, I will do that for all the zeros present in the matrix, and then whatever the final I get, final answer I get, I will return that matrix. But here's the catch: we are required to do that in that operation in place. So it is not allowed to declare a separate array or a separate matrix and do the operations and return that same the new matrix or the new array. So we have to do that in place. So in order to save the space complexity, Leetcode has proposed this condition. So how can we do that? So first of all, we will get to know about the brute force approach. So brute force approach says that I will scan the elements one by one. We'll check for the zeroness of the value. If the value is 0, then we will update the rows and column of that 0th value, and we will continue to do that for all the elements. So essentially, this whole operation will lead us into a time complexity of order of n cube. So which is, I think, the worst case scenario in this problem. So what will happen? We'll have two loops, one for the row and one for the column, and then we will check for the zeroness of the value. And if we found the value is 0, then we'll have another two loops or another nested loop for updating the values of the rows and column into 0. So essentially, it will, in the worst case, it will turn out to be an n cube operation. But there's a problem in this approach. Since we are doing it in place, we need to take care of the values that we are updating. So one problem that I found out is, let's say we have this array or we have this matrix 0, 1, 2, 5, 2, 0, 4, 9, 8. So we are encountering the first 0, which is the first element. So if we update the rows and column of this in corresponding to this value, so we'll have this operation after like processing the first element is we'll have the first row and the first column turned into 0. So since we are doing it in place, we are actually updating the values that were present in the original matrix. So next, when we shift or when we go towards the next element, which we will encounter the second 0, we will encounter this 0. But ideally, we should encounter 1, right? Because in original matrix, this element was 1. Now, because that we are doing it in place, we are actually encountering 0. So what will happen? It will convert this 2, 9 to 0, and similarly, we will perform if we do the whole iteration, we will find out that we are actually converting the whole matrix into 0 matrix. So that to avoid that situation, we need to figure out some another way in order to save the original values and still perform the operation in place. So what I suggest as an optimal solution is we'll scan the elements one by one. So we'll have the two loops for going to each and every element. We'll check for the zeroness of the value. We'll save the column and rows and column numbers into like some variable, and then like after this whole iteration of the matrix, then we will update the rows and columns individually in a separate for loop or in a separate loop. So essentially, this whole operation will turn out to be only an n square complexity. So why n square? Because we'll first iterate through all the elements, which is like n square operation, and then after that iteration, we'll update the rows and columns individually. So which will be kind of an like order of n operation. So, or even you can, in worst case, you can take the order of n square operation. So order of n square plus order of n square is essentially order of n square only. So here we are not performing like nested operation. We are have two different n square operations. So it will turn out to be a single n square operation as the worst case gram complexity. So let's code this out. So we'll first save the length and breadth of the matrix. So we'll have m is equals to length of the given matrix, and as n as the number of columns that we have. So m is the number of rows and n is the number of columns. So we'll have n and m as that, and then I will have a row as a set. So we have to save the rows and column numbers, right? So we need to have two variables for that as well. So here I will be using the set data type for that, because in set it is in kind of an array, but we will only have the distinct values. So, and whenever a new value is appended to the set, it will check for its uniqueness. If the value is unique, then it will be appended. Else it will not be, like, it will be ignored straight away. So and we can check it. We can check that the uniqueness in order of runtime. So this can be a very crucial factor in terms of time complexity. So I will iterate through the loop one by one. So which is order of, like, in using two nested for loops. I'll check if the element is 0 or not. If the element is 0, then I'll append the row numbers, which is I, and I'll append the column number, which is j, and that's it. So at the end of this, this nested for loop, I will be having the row numbers and the column numbers that are to be updated to 0. So now that I have the row numbers and column numbers, I will go through all of it one by one. So I will be having, I'll go through the row numbers present in the row set, and then I will, since we are so we'll be going from rows one by one. So but I have to, like, for each row I have to go through all the columns, right? So for that I have to go through the range of n. So range of n is, I will be traversing all the columns in a particular row, and then I'll be updating the values one by one. So I'll have the I and j is equals to 0. Similarly for columns as well. So the column number that I have saved earlier as well. So now if I use the column numbers as the first iterator, so I have to change that m here to n, and I will change the iterator here as well. So here's a small error that I've made. So we don't have any append operation for set, so we have to use the add, which is an equivalent of append for set operations. So we'll use this add operation. So now that we have changed everything, so here is our test case. Let's try this code if this is working or not. So we don't have to return anything, because it is we are doing it in press, so it will automatically, Leetcode will automatically take the matrix as the matrix which is named as matrix only as the output. Here the code is accepted. Let's try out for something else. Let's take this second test case and see how it goes. There is some error. It might be just about the spaces. Yes, so the code is working on the second test case as well. Let's submit this code. So yes, this code is working more than 93% of the online submissions, so which is quite good for this code, and it is around 70% efficient than the other Python 3 codes. So memory wise and runtime wise, this code is very well, so you can use this code. I will be updating this code in the my GitHub repository as well. That the link you can find in the description box. So that's it in this video, guys. Thank you, guys. Thank you for watching. If you haven't subscribed this channel, please subscribe it to know more about Python and competitive programming. This channel is all about that. So keep liking, keep sharing, keep take care of your health. So we'll meet next time. Thank you.